Next, reaction with CO and BF3. Reaction of ethers with CO and BF3. Have I given this excess amount? Not given, no? Just a second. Sorry. Wait. This is not our. Just I covered few examples only. See, when ether treated with HI 1 mole, when ether treated with HI 2 moles are excess. 2 moles are excess. See, when we treat with 1 mole, we'll get alcohol and alkyl halide. Yesterday I given the mechanism also, complete mechanism. When we treat ether with 2 moles of HI or excess HI, we will get 2 alkyl halides only. 2 alkyl halides only. Very, very important. With excess hydrogen iodide and 1 mole. Let us see one example. HI 1 mole. HI 1 mole. CH3OH plus CH3I. CH3I. HI 2 moles. 2 moles are excess. Then what we will get? 2 moles of iodide only. Methyl iodide. 2 moles of methyl iodide is formed. With excess and with 1 mole. Note down. Bhakti, Mazia, very following. Right. Okay. Next, last reaction. Reaction with then we'll go with the phenols. Reaction with the CO plus BF3. Carbon monoxide and boron trifluoride. See, when ether is treated with the carbon monoxide CO in the presence of BF3, boron trifluoride, remember, ester formation takes place. Ester is formed. How ester is formed? See the trick. Carbon monoxide, sorry, CO, carbonyl, not carbon monoxide, carbonyl group. This group will be inserted in between R and CO. Attach or insert. R, in between R and O, you are inserting this carbonyl group. Okay, and OR is as it is. Let us see one example. Hello? Oh no. Okay. Acha, ikkada connect ayindi. Okay. సృజన్ ఓకే ఓకే ఇప్పుడు కనెక్ట్ చేసేది, ఇప్పుడు కనెక్ట్ చేసేది, అది వేరే ఫోన్ కనెక్ట్ అయింది. నౌ ఐఎమ్ ఆడిబుల్. హలో హలో హలో, ఒక్క నిమిషం, ఇప్పుడు వస్తుంది చూడు. మిస్టేక్ దీనికి కరెక్ట్ అయిపోయింది. One sec now. Hello. Right. Okay, okay. It is connected to this phone actually. Right. So this carbonyl group, CO group will be inserted between oxygen and carbon. Now I will give you one example, then you can understand easily. This one, take screenshot and copy later. Take screenshot. Okay, right. Look at this. CH3O CH3 dimethyl ether, CO and BF3. How to write the product? See the trick. This carbonyl group will be inserted between R and O. Write this CO as C double bond O. Insert. Okay. Carbonyl group will be inserted between alkyl group and oxygen. CH3 C double bond O, OCH. Through OCH3 as it is. Ester formation takes place. Ester is formed. Ester is formed. Clear? This is about the reaction of ethers with the carbonyl group and BF3. Got it? All of you? Completed? Shall we go to next page? Right. This is about ethers. Ethers. Next topic, last topic in the second lesson, phenols. Very, very important chapter. All of you revise resonance effect, then you can understand easily. Okay, about acidic nature or the reactivity of phenol towards electrophile. Okay, you have playlist of general organic chemistry. First watch inductive effect and plus I minus I, then stop just inductive introduction plus I minus I order and stability of carbocations, then directly go to resonance effect, introduction plus M minus M groups, applications of resonance, then you can understand easily, right? Okay, next subtopic, phenols. Okay, Meenakshi, completed. Carry. Right, phenols. Second chapter name is alcohols, phenols and ethers. We completed alcohols, we completed ethers, and the last topic is phenols. Very important. First we will see the nomenclature. Benzene ring with OH group. Benzene ring with OH group is called as phenol. If benzene contains OH group, that is called as phenol. Phenol. Okay. Another name for phenol is carbolic acid. Phenol, another name is carbolic acid. Phenol or carbolic acid. Right. Let us consider it as a first structure. First structure. Important compounds and their names. See, this is phenol, parent compound, phenol. Our chapter name is phenol, so this is the parent compound. If NO2 is present in the ortho position, then we can call it as a ortho nitrophenol. In ortho position, nitro group is present. Ortho nitrophenol. You know, ortho positions on the benzene ring, if two substituents are present in the adjacent positions. See, OH is one substituent, NO2 is one substituent. Both are side by side. That is ortho position. Ortho nitrophenol, or we can give the numbering like this: 1, 2, 3, 4, 5, 6. At second position, nitro group is there, right? Correct only. Now, why we started numbering from this carbon? Because this is connected to functional group OH. That's why numbering should start from this carbon. Got it? This yellow carbon is there, na? That is connected to main OH, alcohol functional group. That's why numbering should start from that only. So, what is its name? Tell me. At second position, what is present? At second position, what is present? Nitro. 2-nitrophenol. 2-nitrophenol. So, ortho-nitrophenol or 2-nitrophenol. Clear? Second position, nitro group is there. Third position, are also called as meta position. Meta. If two substituents are present in the alternative positions, alternate. See, OH, no group, again another group, alternative, not continuous alternation. Group is present, no group, and again group, alternative positions. Are 1-3 positions. Give the numbering: first, second, third, fourth, fifth, and sixth. Its name is meta-nitrophenol. These names are very, very important. Meta-nitro or M-nitrophenol. This is meta position. If any group is present in the third position, that is called meta position. M-nitrophenol, meta-nitrophenol, or also called as, tell me, you try. You try. Numbering, according to numbering, like this: 3-nitrophenol. 3-nitrophenol. Why I am giving the names for these? We will discuss acidic nature. Acidic nature will come in the weekend exams. Remember, the phenol chapter is there every year. I am seeing, right? Relator is, if phenol chapter is present for the weekend exam, one acidic nature question will come, right? And in general organic already we completed acidic nature, but again we will discuss here. But you once revise resonance effect and applications, then you will understand easily, right? I explained briefly about acidic nature. And fourth one, see, in fourth position, 1, 2, 3, 4, 5, and 6. 4-nitrophenol are if two groups are present in opposite directions, completely opposite. That is called as para position. So this is para-nitrophenol. 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 Or para, or we can use P, okay, like this. P-nitro also, we can write P-nitro, or para, complete para. This is meta, M-E-T-A, meta. Or 4-nitrophenol. 4-nitrophenol. We will discuss most important compounds in this chapter first. Why I covered these three? Acidic nature question is very important. Acidic nature comparison of orthonitrophenol, metonitrophenol, paranitrophenol is very important. Of course, you know, some of you know. Srujan, tell me which is more acidic out of 2, 3, 4. Which is more acidic? Guess. Which is having more Ka value? Srujan? Bhakti, can you? Bhakti? Meenakshi, can you say which is having more acidic nature out of 3, 4? 2, 3, 4. First one. Why first one is more acidic? Why first one is strong acid? No, Aishwarya. Kritika, do you know? Majia, did you finish? Oh, I have to reach. Okay. Yeah. Meenakshi, what about you? Meenakshi, what about you? You know already these things. Bhakti, what about you? Obed. Okay. Can you say which is more acidic between 2, 3, 4? Third one, very good. And remaining students, I'll explain again. Clear? Right. Just you learn the names. I'll explain acidic nature in detail. Right. How many compounds names we finished? 4 compounds names. Next continuation. 5th compound. If benzene ring contains OH and a methyl group, that is called as cresol. 6th one, if benzene contains OH and CH3, that is called as cresol. But what is the difference between these two? Tell me. What is the difference between these two? What is the Yes. First one is orthocresol. Next one is metacresol. So when we call particular compound as a cresol, tell me, when benzene contains OH and CH3. Both OH and CH3 is present on the benzene, the total compound is called as cresol. But methyl is in the ortho position, so O-cresol, orthocresol. Methyl is in the meta position, so M-cresol, metacresol. Clear? Next, seventh one. Have you finished this? These two. Have you completed? If two OH groups are present, on the benzene ring, that is called as catechol. You will get questions like this. In your material, you have these questions. Which of the following contains two OH groups? Catechol contains two OH groups. Catechol. If two OH groups are present in meta position, if two OH groups are in ortho, that is catechol. If two OH groups are in meta position, that is resorcinol. You should learn the names, right? Important. Resorcinol. In para position. Hydro. Quinol or quinone, both are same. Hydroquinol or quinone, because it can exist in the keto form also. Catechol, resorcinol, hydroquinol. How to get these things? First, prepare, observe, take white paper, and do practice. Right? Try to draw without seeing. Clear? If you see once like this, you won't get. Later, you won't understand. Clear? So, first, I started phenols freshly. So, prepare the topics day by day, regularly. If you are in advance in your weekend syllabus, then it is easy to score in the weekend exams. Otherwise, last time happened like this. Every means in the last minute, Saturday, Sunday, we could not finish the syllabus also. Even here Sunday, I took classes. So that is not correct. So that's why this time I'm teaching in advance. Here, so you also learn the organic in advance, right? Other track, okay, we can manage in the same way, but if you are in advance at least one track, then it is very easy to score, right? Don't keep pending. Why I'm saying all these things? Start Phenols today only, right? The names, all the things, right? Next, 10th one. If 3 OH groups are present like this, then this is called as fluoroglycinol. Fluoroglycinol. In which of the following 3 OH groups are present? The answer is fluoroglycinol. Fluoroglycinol. 11th one. All are very, very, very important. You can say this easily. Try this. Anybody? Very, very easy. Fluorine is present in which position? Tell me, ortho or meta or para position? Para. So, para, fluorophenol. Yes, para fluorophenol. P fluorophenol. P fluorophenol. Para fluorophenol. Why? Acidic nature comparison is very, very important. Which of the following is more acidic? Option A, parafluorophenol. Option B, parachlorophenol, parabromophenols, paraiodophenol. Very, very important question. Next, shall I clear this? Okay, have you finished? Write another one, and bromide, no need to write because you can say easily. Write another one, p-chlorophenol, parachlorophenol, parabromo, paraido, you can say no problem. So we completed parafluoro, parachloro. If benzene ring contains OH group and the CHO, very, very, very important. Give the symbol, skullman symbol. Skullman symbol, very danger. You know this, when the compound or any formula is very, very important, I'll give the symbols, you know already. Most important structure, its name is very, 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 very important. In the next chapter also it will come. When benzene ring contains OH and CHO, it is called as salicylaldehyde. Salicylaldehyde, or it is also called as another name, orthohydroxy. OH is hydroxy. When OH is present as a substituent, we use hydroxy. Actually, this is the compound of third chapter, actually third lesson. Clear? But OH group is present, so I am giving. So we will get more practice. In next lesson it will come. O-hydroxy. What is O-hydroxy? See, this is the main functional group, aldehyde. You know, in the nomenclature, functional group priority, first carboxylic acid will come, sulfonic acid will come, next ester, okay, acid halide, amide, cyanide. After that, aldehyde, ketone, alcohol, you know, priority order. First carboxylic acid. When CHO and OH is present, What is high priority? Aldehyde is the high priority. So this is the main parent group, this is substituent OH. That's why I'm using hydroxy word. Just you learn it as it is, structure and name. Okay. Orthohydroxy benzaldehyde. Orthohydroxy benzaldehyde, commonly called as salicylaldehyde. In which of the following OH group is present? Option A, catechol. Option B, salicylaldehyde. Salicylaldehyde means it contains only aldehyde, right? It contains only aldehyde because salicylaldehyde is there. OH also present. Catechol means you can identify, whole is present, OH is there. Salicylaldehyde, aldehyde only present. No, that is wrong. In salicylaldehyde, OH group is present. Right? Have you completed all of you? Shall I clear this? Shall I clear this? Next, 14th one. 14th one also very, very, very important. Right. I'm giving the numbering. You try its name, general name, first one, second, third, fourth, fifth, sixth. I'm giving hint to you. See at which position NO2 groups are present? Tell me. Second. Say like this. Second. Fourth. Sixth. 2, 4, 6. 2, 4, 6. Which groups are present? 2, 4, 6 trinitrophenol. At second position, yes, very good. Picric acid, super. Second, fourth, sixth. Commonly it is called as picric acid. I explained in the general organic chemistry. Basic nature of phenols. See, 2, 4, 6 trinitrophenol. Actually, this part is phenol, right? This part is phenol. To the phenol, at second position NO2 is there. Fourth position NO2 is there. Sixth position NO2 is there. 2, 4, 6 trinitrophenol. Commonly it is called as, this common name is very, very important. Commonly it is called as picric acid. Its common name is picric acid. Common name is picric acid. So these are some important structures in the phenol chapter. You should do practice. What is phenol? Another name? At the beginning I given phenol another name. What is phenol another name? Carbolic acid. Carbolic acid. Another name for phenol is carbolic acid. Right, next. Let us see some points about the phenol. Okay, important points about phenol, or we can do like this also, structure. Structure of phenol. I already given structure, but information or other additional details about the structure. This is phenol. This is phenol. Okay. This bond angle, look at this, all of you. Here carbon is present or not? C6H6 benzene. This is carbon, this is carbon, this is carbon, this is carbon, this is carbon. Carbon, oxygen and hydrogen. I am writing oxygen here. Oxygen. carbon and hydrogen. This bond angle. Carbon oxygen or CHO or COH bond angle 109. 109 degrees. 109 degrees. First point about phenol structure. CHO bond angle is 109 degrees. Next, very important point. You have to imagine carbons, but I am removing here. See, this white dot represent carbon. Let us consider X is the bond length between or distance between this carbon and oxygen or bond length. This is oxygen atom, white dot. This is carbon atom, white dot. This is oxygen. Between these two, what is the distance? That is bond length. See, I am taking normal alcohol here. Normal methanol I am taking here, methanol. Let us compare the bond length of carbon and oxygen in alcohol. Already I took X, why I am taking carbon oxygen length. In which carbon oxygen length is more? That is the question. Okay. Why length is more? Why Surujan? What is the reason why is more? Very good. See, resonance. Again, we take the help of first year GOC. Due to resonance, oxygen is having two lone pair of electrons. This lone pair participate in the resonance. So, what happens to this single bond? The single bond will convert it to double bond. Here you will get negative. Once watch the resonance, I given how we will get double bond here. Everything I have given. Now you tell me, due to resonance, this single bond is converting into double bond. Double bond length is more compared to single bond. That's why Y is more. See, bond length of Y is greater than bond length of X. Underline it. Because of resonance. Due to resonance, what happens? This single bond is converting into double bond. Double bond length is less when compared with a single bond. Here there is no chance of resonance. Structural requirement is present. That is the importance of GOC. Clear in every chapter. See, in phenol started now. We started using GOC. So bond angle is given to you and bond length comparisons are given to you. Carbon oxygen bond length in alcohol is greater than carbon oxygen bond length in phenol. That is final conclusion. The length between carbon and oxygen in alcohol is greater than the length between carbon and oxygen in phenol due to resonance. Resonance means shifting of pi electrons or non-bonding electrons. Okay. Now let us keep heading. Acidic nature of phenols. For new students, is very useful to you, and our old students you know already. But listen again. Because in this chapter, acidic nature question is very important. Actually, I am teaching first year basics now, first year basic concept now, because in some chapters first year topics will come again. Okay. For example, ozonolysis reaction is there. That is there in first year alkenes and third chapter of second year organic also common. Okay, some topics are common. Similarly, acidic nature also common. It is in GOS, it is in phenol chapter also. Clear? Now let us start acidic nature. Acidic nature of phenols. Acidic nature. Acidic nature of phenols. Acidic nature. You tell me what is Arrhenius acid definition. How to define Arrhenius acid? According to Arrhenius theory, what is an acid? The substance which gives H plus ions in water. First year ionic equilibrium definition, Arrhenius theory, Bronsted theory, Lewis theory. So many theories are there to explain acidic nature. Right. Just a second. Right. The substance which gives H plus ions when it is dissolved in water is called as an acid. HCl is there, hydrochloric acid. It gives H plus ions when dissolved in water. HCl is giving H plus ions, right? So HCl is an acid. This is general information about acid. Why I given? If you know this idea, this point, then you can understand phenol's acidic nature. Phenols also act as acids by giving H plus ions. We know the one which gives H plus ion is called as acid. Phenol also gives H plus ions when it is dissolved in water. This is phenol OH. O bond H or OH, both are same only, right? See, these are giving H plus ions, so this is also gives H plus ions, and see, oxygen will get negative charge. Why? Here you removed H plus, you kept a negative charge on here. If H plus is removed, immediately write negative charge. This is also first year basic only. Remember, when you remove H plus, put negative charge. Because you removed positive, so negative will develop automatically. When you join both, then charge will neutralize. When you separate, then charge will appear. You are separating, so charge will appear. If you join, then charge will disappear. This is called as phenoxide ion. Its name also very important. This is actually conjugate base. The negatively charged species after removal of H plus from the acid is called as conjugate base. Conjugate base. First year only, conjugate base. If you do not have idea about conjugate base, then Bronsted theory, Bronsted-Lowry theory, conjugate base concept, ionic equilibrium, first year topic. Conjugate base, its another name is phenoxide ion. Phenoxide ion. Particular name is there for this conjugate base. What is its name? Phenoxide ion. Okay. Right. In acids and bases chapter of first year physical chemistry, you discussed about dissociation constants. Dissociation constant, Ka, acid dissociation constant, base dissociation constant, right? See, Ka is the acid dissociation constant. What is the significance of acid dissociation constant? Acid dissociation constant means very simple information. the dissociation constant which gives about strength of acid, means a particular acid is weaker or stronger, will be given by dissociation constant. What is the role of dissociation constant? It tells about a particular acid, whether it is strong acid or weak acid. Just know that point and remove it. So if I ask you what is Ka, it is a dissociation constant. What is its use? It tells about a strength of the acid, whether it is strong acid or weak acid, will be given by dissociation constant. Clear? Right. Acid dissociation constant, Ka. See, if Ka value is more for a particular compound, if Ka value is more for a particular compound or a particular acid, for a particular acid or compound, then its acidic nature is more, then its acidic nature is more. For example, look at this, all of you. Ha is one compound, Hb is one compound. I am giving Ka values. Here Ka value is 2.1. Ka value for this is some 4.1. You tell me which is good acid, which is stronger acid. Which is stronger acid? Whose Ka value? Whose Ka value is more? Hb, 4.1. So this is stronger acid or good acid. Very simple. Just observe the values. Ka value. If Ka value is more, you will get values only, like integer numbers only you will get. Okay. Practically derived data will be given to you. If Ka value is more, if higher is the Ka value, more will be the acidic nature. So this is a basic information from the ionic equilibrium of first year. I given this because we will get questions based on the Ka values in this organic chemistry. We use first year physical also. I revised once. What is a Ka? Ka is a dissociation constant. It tells about the strength of the acid. Means whether acid is strong or weak will be given by Ka. If Ka value is more for a particular compound, its acidic nature will be more. Okay. Completed? All of you? Completed? Shall I clear this? Okay. Look at this, all of you. Ka is directly proportional to acidic nature. If Ka value is more, then acidic nature is more. I given now that point only. Next, pKa. pKa is inversely proportional to acidic nature. How many of you learnt ionic equilibrium perfectly in the first year? How many of you learnt ionic equilibrium? All these terms came in the first year ionic equilibrium or not? See, pKa, what is pKa? I am giving in the bracket, note. Negative logarithm of Ka is called as pKa. Negative logarithm of Ka is called as pKa. Before that I given Ka values, right? Some 2.4 or 4 point something like that I given. Na? If Ka value is more, acidic nature is more, reverse order. pKa is inversely, 1 by means inverse. This is reverse. If pKa value is more, acidic nature is less. Reverse. Okay. Here direct relation is there. If Ka is more, acidic nature is more. This is inverse, reverse relation. If pKa is more, acidic nature is less. Clear? Just to learn the relations. Completed? All of you? Right. Now, The first year topic, resonance applications means we are in the second year only, but again we are doing first year topics. I said already 2 times topics will come. Write plus m groups. Keep heading plus m groups. Plus m groups. Minus m groups. Minus m groups. Minus m groups. What are plus m groups? Electron, donating groups. Electron donating groups. Minus m groups. Electron withdrawing groups. Electron withdrawing groups. In phenols chapter, acidic nature questions are very important. That's why particularly I am explaining this. In alcohol chapter, I didn't explain acidic nature because we covered already in GOC, right? And that alcohol's acidic nature is easy only. If you know inductive effect, then you can answer. But phenol's acidic nature is a little bit tough to understand. That's why I'm again explaining. Right? Okay. I'm giving some plus m groups other than OH. OH also plus m only, but if I write OH again, you will get confusion. So for this topic, okay, in the second year phenols, I'm not writing OH as a plus m, but in the original general organic chemistry, I included that OH also, but here I'm not giving that. I'll tell you why I'm not giving. You will understand soon. NH2, NHR, OR. OR stands for OCH3, OC2, H5, like that. Okay, and ester group also A plus M group. Amide also A plus M group. And the methyl group, actually its effect is hyperconjugation. Temporarily let us write CH3 also under plus M. Okay, actually its nature is not plus M group, but just include, temporarily include. Nothing will happen, temporarily include. In GOC, you will get the clarity about it. So, NH2, NHR, OR, OC, OR, NHCO, RCH3, all these are plus M groups, electron donating groups. Electron donating groups, right? Every plus M group also has which effect? Every plus M group also having some common effect. Plus I. Every plus M group also having plus I. Every plus M group also has minus I effect. Very important. Now see, if I ask you, what is the effect shown by NH2? You should say these are plus M as well as minus I. What is the effect shown by NHR? Where, you know, R is a methyl ethyl. Effect shown by NHR, plus M as well as minus I. OR, plus M as well as minus I. Two effects. See, plus M means electron donating nature. Plus M means electron donating nature. Minus I means electron withdrawing nature. NH2 is having two types of characteristic property. It donates electrons and it withdraws electrons also, but which is taken into consideration in generally plus M effect, mesomeric effect is taken into consideration. This is secondary. I'll tell you when we use minus I. Keep this point in your mind. First give the priority for resonance or mesomeric effect, then only inductive effect. Inductive effect will get least priority. Clear? Finally, the conclusion is every plus M group also has which effect? Minus I effect. Some donating power as well as withdrawing power. Right? There is no 100% perfect object or person in this universe. Right? Good and bad both are there. Similarly, here also donating is there, withdrawing also there. Right? Okay. Did you observe one thing? I didn't include OH here because if I include OH, you will get confusion while doing the questions. Clear? Right. So for new students, for this topic, acidic nature of phenols, what you have to do? You know about plus M definition? Examples. Minus M definition. Minus M means withdrawing group and examples. Right? Temporarily. In GOC, full topic is covered. Right? Watch that videos. NO2 minus M group. Cyanide. These are minus I groups also. In inductive also same groups came 2 times. NO2, cyanide, aldehyde, ketone, carboxylic acid, and see, wait, don't write. Observe these 2 fingers. This finger represents oxygen, this finger represents C double bond. Right? What I did? Swap. C double bond will come this side, O will come this side. Swap here. Then its nature will change. C double bond O. Aldehyde repeated 2 times. Huh? Okay. Right. Carboxylic acid instead of writing COOH. Here also swap this. CO will come here, NH will come here. So ester behaves as both plus M and minus M. Once observe this circles all of you. Ester plus M minus M. Which of the following functional group act as both plus M means donating group and minus M means withdrawing group? What is that functional group? Ester. When it acts as a plus M, when you write oxygen at the terminal. When it acts as a minus M, when you write C double bond at the terminal. Very, very important. Clear? Note down this. Right. One common point for both plus M and minus M groups is minus I effect. Minus I effect. Every plus M group also has minus I. Every minus M also has minus I. Minus I is common for both plus M as well as minus M groups. Clear? Right. What is the use of knowing plus M and minus M groups? To compare the acidic nature of phenols. Right, in phenols we completed nomenclature and we completed structure and we are going to complete acidic nature of phenols. Okay, right. Phenols act as acids by giving H plus ions. Where here? No. Phenol is giving H plus ion. Phenol is giving H plus ion. Phenol act as acid. Right. First, you should remember this statement. How this plus M minus M groups affect the acidic nature of phenol. These 2 statements are very, very important. Minus M groups increase acidic nature. Minus M groups increase acidic nature. Plus M groups decrease acidic nature. Plus M groups decrease acidic nature. See, first example 1. Tell me, physics class, huh? Yeah, yes, correct. One example. NO2 and NH2. You tell me which is a plus M group? Which is a plus M group? Once go back. NH2 is a plus M group. NO2 is a minus M group. See, minus M, this is plus M. What are the statements? Read these 2. Read these 2 statements. Minus M groups increase acidic nature. To this phenol here minus M, actually this is the phenol, this box is phenol. To this phenol which is attached here, NO2 is which group? Minus M. Minus M groups increase acidic nature. NH2 is which group? Plus M. What plus M groups will do? They decrease acidic nature of phenol. So this is more acidic, So this is acidic nature order. So A is more acidic than B. Acidity order A greater than B. Very simple. If you know minus M groups, then you can identify more acidic. To this phenol, minus M is attached. So this is more acidic. Okay, right. We will continue in the next class. After that, I will give you